Going ahead, few secure network components which you should be aware of generally. What is an intranet? Intranet is a network which you create for your own self. Okay. And you might have your own routers and you might have your own complete network. Your intranet is basically when the routers and your internal networks are working only for your own. You are using TCP/IP, but it is not connected to the internet directly. Okay. So it is your own internal network. Extranet is when you establish this intranet over the internet. Okay. So basically what you do, you have your own router, but this router now is on your internal IP over the internet. In intranet, the entire network is yours. In extranet, you are utilizing internet to tunnel your intranet traffic through the internet. Okay. Then you have something called screened subnet or a DMZ. Screened subnet is once you create a network, okay, you have a router, okay, you have a firewall in between, okay, and you create a network so that you can monitor it. Okay, you want to monitor this network. So what happens is hackers generally, and you have some vulnerabilities and people come and do something, and so that you can watch their activities. Screen subnets can also be used for deploying your honeypots and honeynets. Basically, you want to watch what are the hackers doing. Okay. Then you have something called a screened host. A screened host is on your network. Okay. Before you put a firewall, okay, you have a bastion or a screened host. Bastion or screened. Basically, if you are an external entity who wants a connectivity to an internal server, okay, you first authenticate yourself to the bastion host, then bastion host lets you connect to your internal resource. So basically it's a screened host. It screens who is trying to connect to the main server. Okay, that's called a bastion server. Now, to protect your network devices is very important that you protect its availability. And to protect its availability, you have to control, physical security requirements, power supply issues, hardware support, who is going to repair your, equipment, and proper configuration management of the hardware. Then only you will be able to make the, network run securely. Okay. Some few common, network equipments which you should be generally aware of are repeaters. Repeaters help you in making your network reach a slightly more ahead. Hubs were first generation devices for connecting your networks. Modems are basically a term for modulation, demodulation. They help you connect to your internet service providers. Bridges are if you have two switches, you want to connect them and make one switch. This is called bridging. Okay, you connect it uses bridges. Switches are layer 2 and layer 3 devices which help you connect your clients directly. Okay. Then you have routers which work on the network layer and they help you in connecting to your any network outside your enterprise network. LAN extenders which help you in, if your switch is here and you have some device 10 kilometers away, you can put a LAN extender and you can extend your LAN to a slightly far off place. Okay. Bastion host I have already explained. Then you have sensors for security monitors and security automation devices. You put sensors in your network which collect data from your network and give it to SIEM and SOAR systems. Basically, security incident and event management and security orchestration and response. Basically, these are systems which help you in responding to any network level threats. Their sensors are put on your local network devices, which export the data out of your network and send it to those systems. Those sensors, basically are nothing but log collectors. They collect log from different devices and send it to your correlation devices. Okay. You can also have aggregators. Aggregators are basically network devices which aggregate a lot of different kind of networks into one network. Basically, what happens is, say if your you have your internal network and your router is connected to ISP1, ISP2, and ISP3. This ISP provides internet on OFC. This provides on satellite. This provides you on maybe copper. So you basically put an aggregator for your network to be visible as one single outward network. Okay, that's called aggregation of network. Okay, whenever you create networks, there are two domains. One is called collision domain and one is called broadcast domain. What is a collision domain? Collision domain is whenever in a network, if there are multiple clients and when they try to do some kind of a transmission, and if due to that collision happens, okay, there is a possibility of collision, that syslog server, oh yes, very much somewhere syslog server is very much relevant today. Okay, right, there are organizations who don't know what is syslog, so the syslog server is very, very relevant even today, right? Syslog servers, then aggregation servers, very, very relevant today. Okay, so you have because today if you don't have a syslog server, you take all your logs into syslog and then transport it to SIEM. That is a much better way. These days, SIEM servers put a syslog server in front of them so that to ingest all the logs. Right. Collision domain is when the network is designed in such a manner that if two clients send data at the same time, it will result into a collision. Okay, that means there is no controller who is controlling transmission of information on a single bus, because this is one single network bus on which everybody is connected. So if I send a packet at same time, it might lead into a collision. Such kind of networks are called collision domains. A switch is a collision domain, because in switch you can transmit anytime. If there is a collision, then the network halts you for some time and again resumes transmission. Whereas the moment you put a if there's a switch and ahead of it you put a router, then what happens is it becomes a broadcast domain. What happens is anybody can now send his data. Though collision will happen here, this is a collision domain, but any data moving out of it is a broadcast domain, because no data will be rejected. Router will send your entire communication out, and that's called a broadcast domains. Okay. Now, network access control is a very, very important way of securing your network. So network access control basically means all your network devices, who has the access to those network devices. Okay, you might have clients who are trying to access switches. You might have switches trying to access routers. You might have clients trying to access your wireless hotspots, which are then in turn trying to access the network. So at each edge, you have a network access control. And that is basically identification and authentication and authorization. Okay. Generally, at network level, this is done using something called a NACL, Network Access Control List. Okay. Network Access Control List basically tells what are you allowed to do on the network. Firewalls are one of the major devices which are put on networks to have some kind of a security between an internal network and a external network. Okay, this is a sign of a router. Okay, so this is your internal network and this is your external network. So firewalls are in between, put to segregate your internal from external networks. Firewalls have now, over a period of time, have a lot of capability, and presently the generation of firewalls are called next generation firewalls, which have the capability to do deep packet inspection. They can go deep inside the packet and see whether there are any malwares or not. Okay, but firewalls generally work on allow, deny, list. So they basically see what is the source, what is the destination, is it allowed or is it not allowed. Basically nothing but a NACL, NACL. Okay, there are many kinds of firewalls. Static packet filtering firewall. Static packet filtering firewall is a firewall. A packet comes to it. It sees the packets. What is the source? what is the destination. If it is allowed, it will allow. Otherwise, it will drop. Then there are application level firewalls. Application level firewalls see the packet, which application it is coming from, and which application it is going to. If it is allowed, then it will allow. Then you have circuit level firewalls. Circuit level firewalls work at session layer. That is, they look at the port number, they look at the IP and the port number. Based on this IP and port matching, if it is allowed, they allow the connection. That's such firewalls are called circuit level firewalls. Then you have stateful inspection firewalls. Stateful inspection firewalls are, firewall is there. I have asked to go to google.com. Google.com is allowed. Once google.com replies, the firewall knows that the internal client had asked for a permission to go to google.com. That means google.com replying to this user is an authorized connection. It is aware of the state of the connection. Such firewalls are called stateful inspection firewalls. And then you have new generation firewalls, which have multifunction devices. It can do IPS, IDS, it can do network inspection, it can do application level inspection. And then you have the inter-segmentation firewalls. Within an enterprise, if there are multiple switches, multiple networks, to segregate each and every network component, you can have small firewalls in between to implement something called zero trust security. Okay. So inter-segmentation firewalls are inside your enterprise to segregate small network perimeters. Proxies are devices which allow you to inspect packets. So you have an internal network. Once you send a packet outside to the router, before the router, there sits something called a proxy. The proxy helps in inspecting what kind of information is going. A firewall is nothing but actually a proxy. Okay. So proxy sits in between and sees what you are doing. If it is allowed, it allows you to go ahead. Okay. A proxy can be forward or reverse. Forward means, okay, I want to go to google.com, right? So I get the request. I say, okay, who has requested? Client A has requested. Okay, then I inspect. I send a request, but not to client A. I send a request from proxy. So when the request comes to google.com, google.com doesn't know that client A requested. Google.com thinks that proxy has requested. So all data is sent through proxy, all data is received at proxy. So what happens? You can implement a lot of policies on proxy. Got it? That is the task of proxy. Proxy makes your internal network invisible to the external work. So that is why proxies are a good concept. Forward proxies are who handle data going from internal network to external network. Reverse proxies are who handle data coming from external networks to your internal networks. Transparent proxies are user doesn't come to know that there is a proxy sitting between. Okay, it's a transparent. So client thinks that he's making a direct request to the google.com, whereas there is someone sitting in between who is disassociating his request, putting his own packet and then sending the request. That's called a transparent proxy. You don't come to know. Non-transparent proxy is once you make a request, you are aware that there is a proxy sitting in between who will change the packet and send the request outside. Then you also have content /URL filtering. On the firewall, there is there's option that you don't want Facebook to be Instagram to be accessed to. You can implement all that on your firewalls. That is called content or URL filtering. And finally comes the endpoint security. Endpoint security is basically your devices, your clients who are servers, which needs to be protected. And other than anti-malware and antivirus systems, you have something called EDR, MDR, and XDR. So what's an EDR? An EDR is endpoint detection and response. What happens is from a system, lot of data, telemetry data is transported out into a EDR manager, okay, which correlates all these signatures with known threat intel database. And if it sees a threat which has not been caught by antivirus and anti-malware solution, it can respond and contain the situation in your endpoint. Endpoint means your laptop, your mobile, or your server. MDR is when somebody else manages this EDR, some reputed body, some more qualified people are managing that MDR. So you can go to CrowdStrike. CrowdStrike is an MDR. It manages the entire detection and response for you. Okay, because you don't have the capability, so it manages it for you. So there's the MDR. XDR services are when service providers, they collect a lot of telemetry data from your network, from your endpoint, from your proxies, from your firewalls, they carry from your applications, they take a lot of data from such devices, correlate, and then do a response. That is called XDR, extended detection and response. Okay. Last part of this is transmission technologies. Now, transmission technologies is basically layer one, the how your data will actually transmit over your network. So there are multiple ways in which your data can be transmitted. You can use coaxial cables, you can use baseband broadband cables, you can use twisted copper cables, which is your UTP cable, which you would have seen. You can use fiber optic cables. Okay, so these days primarily, fiber optic cables are used for WAN networks. Even networks going out from your house are also fiber optic based because they've become cheaper, right? Network topologies. Once you create a network inside your enterprise or in system, you can create certain topologies. The first topology, which was the erstwhile generation one topology, was the ring topology. Ring topology is when you connect all the computers in a ring, and whosoever wants to transmit, you need to have a token. Whosoever has a token can transmit on the network. Then you have bus topology. The bus topology is the one single wire on which multiple clients are connected. This is how basically switches are done. Okay. So bus topology is basically one single bus of cable on which multiple, multiple devices are connected. It uses a listener. Why it uses a listener? To listen if there is a collision or not. The moment there is a collision, it tells everybody to stop transmitting. Okay, that is how bus topology works. Bus could be linear or tree based. Then you have star topology. Star topology is nothing but a bus inside a box. So you take a small box inside it, which is a bus, and then you connect multiple devices. Okay, looks like a star topology. Okay, most commonly used in our homes. Then you have mesh topology. Mesh topology is when you connect multiple devices into a mesh. Routers are connected in this particular arrangement. What does it provide? Multiple segment failures. If there are multiple segment failures, it can take on any link breaks. There are multiple links available between, endpoints. So what happens? Routers are generally connected in this manner. One of the most common, transmission technology inside your LAN, inside your enterprise system is the Ethernet. Ethernet is a local area network technology, right? Today, Ethernet can support up to 10 Gbps on fiber. Okay, you have fiber directly coming onto your PC and you're connected to the fiber. It could go as fast as 10 Gbps. It is called 10G Ethernet. Okay. Generally, as of now, switches which have UTP cable coming out of it are generally 1G. Okay, 1 Gbps switches. Now, there are a lot of type of transmission technologies which are used to transmit your signal on the transmission medium. Okay, first is analog and digital. You can transmit your signal in an analog manner, whereas your signal is continuous, or in digital manner where your signal is in bits. Okay, construction of digital signals is easier. Analog signals, they get a lot of interference. Systems also transmit based on synchronous and asynchronous. Synchronous is when a transmission is dependent on time. Okay, there is time synchronization between A and B. So A knows that I have to transmit at every 1 millisecond, then only B will be able to listen to me at 1 millisecond. So there is time synchronization. Does email require time synchronization? You don't require time synchronization for email. But for us to come at a proper time, 6:30, for starting the class, we needed synchronization of time. And that's why we've created a group so that I can tell you at what time we need to start the class. Such communication is called synchronous communication because we're dependent on time. Asynchronous communications are not dependent on time, right? They have packet headers, okay, which tell you where to reach, right? And that's why they are called asynchronous communications. Then you have something called baseband and broadband. Baseband signals are signals which transmit only one single frequency. Okay, they transmit only one single frequency. That's why their capability to transmit data is very limited. Whereas broadband signals can transmit lot of frequencies, and that's why they can carry more data. Okay, broadcast is when you transmit a signal for everyone. Okay, anybody can listen to it. Multicast is when you send a signal to only few of the entire broadcast list. So you have a big broadcast list, okay, but you send signal only to few limited people. That's called a multicast. Okay, and then you have unicast. In a big gathering, you are sending signal only for one person. Okay? That is called a unicast. Now, when your network devices, they want to access the media could be optical fiber cable or copper cable, right? They have to sense this medium, whether this medium is available or not. Okay, so before they sense this medium, they use two kind of protocol. One is called a carrier sense multiple access collision detection, carrier sense multiple access collision avoidance. Now these are the technologies used on your switches. Now let me explain you collision detection and collision avoidance. Collision detection is, there are say 10 computers connected on this PC, right? And there is a listener. Okay, the moment I send a packet and this guy also sends a packet, say this leads into a collision. The moment this leads into a collision, what the listener does is it sends a very strong spike signal on the medium. It sends a spike signal. This spike signal is received by everyone. Everybody receives a spike signal. They come to know that since there's a spike signal, that means there is a collision which happened, and they all stop their transmission for random amount of time. They all stop for transmission random amount of time. And then again they start transmitting. If there is a collision, again there is a spike signal. Such kind of commission is called collision detection. That means the moment there is a collision, you stop transmitting. And then there is another media access called collision avoidance. Collision avoidance is you have a medium, okay, and you do not want to have a collision. That means my time slot is defined. I have a defined slot. I can only transmit at every 3rd millisecond. He can transmit at every 4th millisecond. This guy can only transmit at every 5th millisecond. This guy can transmit at every 6th millisecond. That is, I have defined slots. What will happen? I will transmit only at every 3rd millisecond. So what will happen? There will be no collision which will happen. So this is collision avoidance. Wireless devices, hotspots, they work on this methodology, collision avoidance. Right? Then you can also have token passing. You have one network. There are a lot of computers here. Who has a token can transmit. Once he has transmitted, he passes on the token to the next guy. If the next guy doesn't want to transmit, he will transmit, else he will pass the token to next one. And finally is polling. Polling is, I have multiple devices connected. I ask everyone, hey, who wants to transmit? Whosoever sends me a signal, he is allowed to transmit on the network. That kind of transmit.
Thank you for watching. Don't forget to subscribe our channel.